We are going to learn how to find the x and y intercepts of a polynomial function and then identify the correct graph. So this particular polynomial function happens to be a quadratic. When we start out finding our x-intercepts, you always find x-intercepts by letting your y equal to 0. And remember, in function notation, g of x represents my y. Now, if we're lucky, hopefully this particular quadratic factors. If not, we have to do the quadratic formula. So in this case, we'll try to factor first. X squared I can break apart as x times x. When I think of factors of -5 that I want to add up to -4, if you think of -5 times +1, not negative, +1, that would multiply to give you -5 and add up to -4. So my factors are -5 and +1. If we set each factor equal to 0, so if x minus 5 is equal to 0 and we solve, one of my x-intercepts will be 5. Now, because they want us to write it as an ordered pair, we would actually write that as 5, 0. My other factor was x plus 1, so if we set that equal to 0, subtract 1 on both sides, then that x-intercept ends up being -1. And as an ordered pair, we would have to write that as -1, 0. Now, when we get ready to find a y-intercept, we find a y-intercept by letting our x be 0. So in place of the g of x, I'm just going to put y. And then everywhere I see an x up here, I'm going to put 0 in. So I'd have 0 squared minus 4 times 0 minus 5. So you'll notice in that case, I get a 0 minus 5, which is -5. And when I write that as an ordered pair, remember my x was 0 and my y is -5. Okay, so if we look for these points on the graph, when I look at this first graph, I don't see the point at 5, 0, so that cannot be the correct graph. This one has the point 5, 0, and then actually they all do. So in that case, we've only eliminated the first graph. Okay, the next point I'm looking for is -1, 0, so this graph appears to have it. So does this one, and so does that one. So I can't eliminate anything on that. All right, when I look for my y-intercept at 0, -5, it looks like these are going by 5, so this graph does not appear to have that, so I can throw it out. This particular graph does, but this one does not. It is at +5. So just on the points alone, we have identified the graph. But one other thing that I will tell you is that if your highest power of x is an even number, you should get a U-shaped graph. And then if you look in front of that term, if your coefficient is positive, which in this case it's understood to be a +1, the U should open up. So just on graph shapes, you could have narrowed it down to these two here. And so it wouldn't have been, because this one's opening down. And then this N shape, that's going to come when you've got odd powers of x. So anytime you have an odd power of x, you would have an N shape. So that's something else, is you could use your knowledge of graph shapes. Okay, in our second example, notice they already have it factored for us, but they're still wanting us to find our x and y intercepts and then express them as ordered pairs and identify the correct graph. So again, I'm going to start with my x-intercepts, which means I let the y be 0, so g of x is my y again. And like I said, luckily for me, they already have it in a factored form. So that means all I have to do at this point is set each factor equal to 0 and solve it. So if x minus 1 is equal to 0, I add 1 to both sides. I have an x-intercept of 1. So as an ordered pair, that would be 1, 0. If x plus 4 is equal to 0, I subtract 4 on both sides. I get an x-intercept. X is equal to -4. And again, as an ordered pair, I would write that as -4, 0. And then finally, if the factor 6 minus x is equal to 0, I think in this case I would move the x just to make it positive and make fewer steps. Doesn't matter which side x is on. So 6 equals x equals 6. So my third x-intercept would be 6, 0. We'll put commas between those since there are 3 of them. Okay, so then next, if we look for the y-intercept, that's where we let our x be 0. So again, in place of that g of x, I'm just going to put the variable y. And in place of all the x's, I'll plug in a 0. So I'll get a 0 minus 1 times a 0 plus 4 times 6 minus 0. So in this case, I have negative 1 times positive 4 times positive 6. So negative 1 times 4 would be negative 4 times 6 would be negative 24. So as an ordered pair, that would be the point 0, negative 24. Now, notice that all of these graphs have what I consider end shapes. Some are forwards ends, like this one, and some are backwards ends, like this one. And so when you're dealing with graph shapes, that end shape comes from having a degree, or your highest power of x, being a odd number. And we're not going to multiply it out, but I just wanted to show you if you were to multiply it out and we just looked at the x's, x times x would be x squared times negative x, you would have a leading term that's negative x cubed. So the power being odd would tell you you've got an end shape. The fact that there's a minus in front of it would tell you that it's a backwards end. So just off of graph shapes, you could eliminate these bottom 2 graphs. Now we'll talk about how else you can eliminate them, but that's one thing to look at. All right, if we look for our intercepts on the graph, so 1, 0, 1, 0, 1, 0, they all have that x-intercept. So the next one I'm looking for is negative 4, 0. So notice right here that's missing. So that graph would be thrown out. This one has negative 4, 0. This one has negative 4, 0. And so does that one. And then I'm looking for 6, 0. So this graph has a 6, 0. This graph has a 6, 0. And that graph has a 6, 0. Now if we knew graph shapes, we'd already be down to knowing this is our answer. But if we didn't, then the last thing we would check for is this y-intercept. So you'll notice that this particular graph appears to be crossing at negative 24. This one we can't see where it's crossing, but obviously it's way up here, which is not going to be a negative number. And then this is also not a negative number. So just based off the y-intercept, those graphs would also be eliminated there.